If we've got a list of numbers, the way to find the average is add them up and divide by however many there are. Instead of adding, we're going to be using integration. That's basically the way to add up the values of a function. Excuse me. So the height function starts at a height of 6. The ball eventually hits the ground, and we need to find out when the ball hits the ground. So we need to know what's this time interval, or in other words, how long did it take to land. And so like I said, we're going to be using integration to add up the function, and instead of dividing by the number of numbers we have, we're going to be dividing by the length of this time interval. So we need to know when does this thing, the height, equals 0. And we can use the quadratic formula. Divided by 2 times the a. So if I use this negative, and this being negative, all the negatives will cancel at the end, and I'll get the one positive answer. So I'm just going to use the negative 40 subtract the square root, and then in here I've got positive 24 times 16, close the radical and the numerator, divided by negative 32. So it takes 2.642 seconds until the ball hits the ground. So from 0 to 2.642. Okay. Now the question actually asks not for the height, but velocity. So with this being the height, I could take the derivative and get the velocity function. So negative 32t plus 40. That's the function we're going to integrate, and then we're going to divide by the length of this interval. So the average velocity is going to be, so technically the definition says take 1 divided by, and then you subtract these two numbers, and then integrate from the smaller one to the bigger one, the velocity. So I'll have 1 over 2.642, and then when you integrate this, it's going to be, this is t squared over 2, and then this would be 40t. So evaluate that from 0 to 2.642, and what have we got? So I'll do this part in a moment. Let me do this. Negative 16 and 2.642 is squared plus 40 times 2.642. And then that needs to be divided by 2.642. So it's an average of negative 2.272 feet per second is the average velocity. So right about here at the vertex is when it reaches the top. So it spends this much time going up, it spends this much time going down, and if you're talking about, if that were the end of the subject, the average velocity would be 0, because it's symmetric, and however much velocity it had going that way, it's going to have negative velocity that way. So then those two cancel each other out. What's left is from there down to the ground. And so negative means that is going down, and the average is 2.272 feet per second, so it's not real fast for the average.